There are four different types of general purpose registers. The general purpose registers are AX, BX, CX, and DX. So, where these are all 16-bit registers, and again AX is divided as AL and AH, BX is divided as PL and BH, and CX is CL and CH, and DX is D and DH, where all these four, there's 8 different general purpose registers are 8 bits. Each AL is 8 bits, AH is 8 bits, and so on. So, the first type of instruction, we should be very clear about these general purpose registers, and the first type of instruction is add. So, add BL, comma, CL. If I say the instruction, then what does this instruction give us? Means it will add BL plus CL, the data available in BL register and CL register, and places this data in BL register. So the destination register will be always the first register in the instruction. So as the 8086 is a 16-bit processor, it can do, as 8086 is a 16-bit, it can do either 16-bit operation or 8-bit operation also. So it can do both the operations. So therefore addition can be an 8-bit or a 16-bit. So for example, if I say, if I want to add two 16-bit numbers, then I'll say simply add BX, comma, CX. So what does this give? BX plus CX, as BX and CX are 16 bits, so the value will be placed in BX. So the first register, the value will be placed in the first register. So when we are adding 8-bit number, we are expecting the result to be an 8-bit, or that will be stored in the BL register. So if we are adding 8 bits data, the maximum result may be, for example, I'll take an example. Like for example, I'm saying FF worst case 01H. Now if I'm adding two numbers like this, so what is FF? 1, 1, 1 and 1, 1, 1, 1 and 1, 0, 0, 0, 0, 0, 0, 0 and 1. So if I add these two numbers, so 1 plus 1 will be 0. So there will be again a carry. So 0, a carry, 0, a carry, 0, and so on. All the numbers. If I go on adding, there will be a carry coming out of the most significant bit. So if I add two 8-bit numbers, the maximum result, maximum size of the result at the most may be 9 bits. At the most may be 9 bits. So the 9th bit will be the carry. It cannot be more than this 9 bits. So like what when we are adding 99 plus 1, what is the result we will be getting is 100. So in the same way, when I'm adding the worst case scenario, that is FF plus 01, then we will be getting the maximum value may be around that is ninth bit, that there will be carry to the ninth. Okay. Now, worst case scenario. Now, if I go with the worst case, so the worst case means if I add something like two 8-bit numbers FFH plus FFH. So then what will be happening? 1, 1, 1 and 1. So 1, 1, 1, 1. So it will be 1, 1, 1, 1, 1, 1, 1, 1. So if I add these two numbers, so it will be 0, carry, carry, carry and so on. I am placing this carry for convenience. So it will be 1, 1 and 1. So 1, 1, 1, 1. And there will be a carry coming out of this particular most segment. This is carry. So when I add two large, the worst case scenario, that is FF plus FF, that will be FE, that is we are getting a values 1 FE, where FE is stored in BL register and 1 is stored in carry flag. So if I am adding two numbers, the first thing we have to remember is if I add two numbers, there may be a 9th bit occurring, that may be a carry flag number. So if I am adding two different numbers, if I'm writing a program, I have to look at even the carry flag, so that if I don't look at the carry flag, there may be chances that the answer may be wrong. Okay, so this is the first one, that is adding. Excuse me. The second one is ADC. So ADC means add with carry. So what does this say means? What does this say means? It is okay. The next type of instruction is add with carry. So what does this do is, if for example, I'm writing the same instruction saying that ADC BL comma CL. What does it do means, it will add the same thing BL plus CL but with carry flag. That is, this will be stored in BL again. So carry flag is a bit, it can be either 0 or 1. So if a carry flag is 0, then it's simply, if a CF is equal to 0, then BL will be BL plus CL. If carry flag is equal to 1, then BL will be BL plus CL plus CF. That's so the question over here is, where do we use this ADC? That is, add with carry. And the other question over here is, the second question over here is this the carry before the instruction took place, or is this the carry after the instruction took place? So the two questions are, I'm repeating again. So the first question is, where do we use this particular instruction? The first question. The second question is, second question is the carry before the instruction took place or after the instruction took place. So we'll take the first scenario. Okay, when if I say if this is the carry after the instruction took place, the first scenario. So if that is the case, how can, if I say, I will take an example, I will say 8 plus some 6. So it will be equal to 4. There is a carry over here. So I cannot take a carry from this and make 4 plus 1 to make it 5. So this is not the way that we do. So it cannot be a carry after the instruction took place. So definitely it is the carry of the previous operation. So it is the carry after the operation. So our instruction. Okay. So if this is the carry of the previous operation, where did we use this instruction? So the second question. So we are very clear that this is the carry which took place after the instruction. So now the next question we want to answer is where this add with carry is used. So this is used when we want to add two large numbers. That is, it is used where we want to add two large numbers. So what are the two large numbers means? Either it may be a 16-bit, 32-bit, or 64 bits. Say for example, I'll take 12 F and 0 0 1 H. So it is something like 0 0 0 1 0 0 1 0 1 1 1 1 1 1 1 1. So 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 1. So if I add this entire 16-bit number, that is 0 1 0 1 0 1 carry 0 1 0 0 0 0. So there is a carry from this one. So 1 1 0 0 1 0 0 0. So what we are doing, we can directly like something like, if I say it is 0 0 1 3 1. So H, or I will say 1. This is 3 0 and 0. So in whatever way we do, there is no problem for us. But if as 8086 is a 16-bit microprocessor, I can directly write something like move, okay, into BX, the value called 12 FFH. So where this is this is one, we know already this is, what is the type of addressing mode we can say? This is addressing mode is immediate addressing mode. So move into CX, the value called 0001H. So I can directly add BX comma CX. So what does this instruction say give me? It will add BX plus CX, and that addition will be placed in DX register. See, suppose you want to add it as two 8-bit numbers. Now the problem is, now if I want to add it as two 8-bit numbers, what I will do? I have to partition this as two 8-bit numbers. The first thing is it will add FF plus 0, 1. Then it will be adding 12 plus 0, 0, 0. So if there is a carry coming out of this first most significant bit of the first 8 bits, then if I don't add it with this carry flag, then the result will be same as 1, 2 itself. So what I will be getting in this particular case, if I don't have ADC, then what will happen? I will not be able to obtain this particular result. So what I will be doing over here is, I will place into the register, move, I'll rewrite this, adding 2 as 2 8-bit numbers. So move into BX, the value card called FFH. Okay, move into CX, the value called 0001H. And what I'll be doing is add BL comma CL. So in this instruction, what I'll be doing, BL will get a value of BL plus CL. So after this, I will write down ADC BH comma CH. That implies BH will have a value BH plus CH plus the carry flag value. So as 8086 is a 16-bit processor, there is no need to do this particular program. We can write it down directly like this program. But if I want to add more than 16 bits, that is 32 bits or 64 bits, then I have to go with this particular type of instruction called ADC. Okay, so this is what the ADC signifies. So the next type of instruction in this particular arithmetic instructions are SUB, that is subtract. So in the subtract, what I'll be doing is, I'll come up with an example, BL comma CL. So we'll do 8-bit subtraction. The moment I say BL, it is an 8-bit. So processor recognizes that we are trying to subtract 2 8-bit numbers. So what it does, BL minus CL, and the result will be stored again in BL. So here also I will be having a carry, but the carry is not the extra bit, but what I will be getting is, I will be having a borrow in this particular case. So as we are doing 8-bit subtraction, the result may be an 8-bit, and the carry here is, carry over here is the borrow. It is not subtract, it is not the extra carry. So it is this borrow is stored in carry flag. So during addition, if there is a carry, the carry flag becomes 1. During subtraction, if there is a carry, if there is a borrow, that is, if there is a borrow, the carry flag becomes 1. So we are clear about these terms. Okay. So during the addition, what will we get? If I am having a carry, then CF will become 1 when there is a carry. So in addition, but in subtraction, carry flag becomes 1 if there is a borrow. Clear? So the next type of instruction is SBR. B. So by this time you might have understood subtract with borrow. The same is the case with what we have discussed in ADC, that is aid with carry. Here it is subtract with borrow. So what does it give? If I say SBB BL comma CL, then BL will have a value BL minus CL minus CF. Here also the value of CF is either 0 or 1. So if CF is equal to 0, then it will be normally BL minus CL. If it is 1, if there is a borrow, then BL will become BL minus CL minus CF. That's it. So we'll take an example and we'll try to figure out this one. So that is, we take an example to explain. 48 minus 29. So I'm taking a decimal in here. Okay, the concept is same, but whatever we're doing is it is a decimal. So when I'm taking this one, so what I will be getting 48 minus 1. So I'll be getting 9. So here there is a borrow. Here the processor will look at the carry flag and subtract from the higher bit. Okay, clear? So the next type of instruction in this particular arithmetic instruction is increment. That is, with an example, INC BL. So what does it do? It gives BL as BL plus 1. BL plus 1. So if BL is plus 5, the incremented value will be as so if BL is 5, if BL is equal to 5, so then if I say increment BL, then the BL value will be uh, 5 plus 1, that is equal to 6, and so on. So for example, in our case, if BL is equal to FF, then the incremented value will be FF plus 1, that will be stored in BL, that is equal to 0. That is, it will be rolled back to obtain a value called 0. So any 8-bit value, any 8-bit value starts from 0, 0, goes all the way to FF, that is 0, 0, all the way to FFH, and after reaching FF, it will roll back to 0, 0. That's all. Okay. So there is definitely so this is the increment instruction. So the next instruction we'll be looking at is decrement. Decrement. So what is decrement? D E C B L. So what it will be doing? BL will get a value BL minus 1. So if BL is plus 5, so same, I'll take the same example. If BL is equal to 5, then if I say decrement BL, so BL will get the value 5 minus 1, that is equal to 4. So and so on, and till 0, 0. If I say more decrements, it will be reaching 0, 0. After reaching 0, 0, it will become minus, it will become minus 1. That is 0 minus 0, 1 h. So if I take a minus 0, 1 h, if it is a negative number, so I have to take 2's complement. So if I say 2's complement means it will become like 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. And if I say 1's complement, so it will be 0, 1, 1, 1. So because there is a carry, okay. So it will be 1, 1, 1, and 1. So, ones complement, it will be ones complement. So, to this ones complement, what I will be doing is I will be adding a 1. So, it becomes totally 1, 1, 1, 1, 1, 1, 1, 1, which is F, F, H. So, if I go back, after decrementing, reaching to 0, 0, it will again roll back to FF, H. It will again roll back to FF, H. So, this is the primary things. So, we'll be looking at a few more arithmetic instructions in the next video. Thank you.